Hi all. Hello everybody. This is Dr. Madhavi, working as an associate professor from the Marri Laxman Reddy Institute of Technology and Management. Now, I am going to discuss which is very important topic, and without that we cannot live. That is the water. Water and its treatment, which is the first unit in the for the BTech first year engineering students. What is a water? Many of you know about the water. What is the importance of the water? Everybody knows. Right. Now see, here the importance of the water, everybody we know that, like an air, without that we cannot live, which is very important. And the uses as a common, that is a common uses of the water, everybody we know that is for the drinking, cooking and bathing, for the farming. All these purposes will generally everybody will use it, but only few of them know about the as an engineering material. Water, which is an engineering material now, that is a which is very important for the engineering students to understand that is why it has been researched for the BTech students. Okay, so we'll discuss what is the importance of the water as an engineering material. That is, here as an engineering material, it is used for the production of the steam. What is the use of the water? That is a steam which is used in the hydro, that is a generation of the hydroelectric power generation, which is nowadays which is very important for us. Instead of depending upon the other sources, that is a we need to depend upon the water for the generation of the power. Through the so for that generation of the power, we need to produce the steam, that is hydroelectric power. Not only that, here as an it is also used for the engineering students. Engineering material, one of the another application is in the construction material, which is very important, well known by the civil engineering students about that construction as a construction material. In the case of the manufacturing, that is a plastering, everything that is during the construction field, right? Okay, then now we need to discuss, as we got to know the importance of the water, from where this water we will get, that is called as a source of the water. So here the source of the water is a main source. Many of them we know about that is the main source of the water is, especially the important source is a rain, a river, spring and the sea water. These are the different sources of the water we'll get. That is, see, and also you know that, see, our earth, most of the 70% of the earth is covered with the water only, right? Some of the water we can see, the outside water as well as underground water is also there, which we cannot see but we can find, right? So here now we'll discuss all the sources. What are the sources? That is as we discussed the different signs, rain, which is a purest. Now the rainwater is the purest form of the natural water. And but even though it is a natural water, while coming from the top to the ground level, it involves the dissolution of number of the gases which are present in the air. Now during its journey through that, so here that is a rain. From the rain, that is it will come into the rivers. So rivers are formed by the rain in the spring, that we also know about that. Now even though it is a river, that is a rainwater is a pure form, it involves the dissolution of the number of gases from the atmosphere. Not only that, when it comes to the ground state in the form of the river, here also it is having the number of the dissolved minerals in the soils which are present. They are the chlorides, sulfates, bicarbonates, sodium, magnesium, all these are the ions, chemicals, that is a substance which are there in the dissolved form. Right, that is one of the source. Another is a well, a spring or the well or the lake water. It contains different types of the chemical compositions present in that. High quantity of the organic matter also there in the well water. Along with that, that is which is the largest area of the earth is covered with the sea water only. No, how the sea water will be there, that we'll also discuss here. And it is the most impure form of the natural water. Why it is impure? Because it involves the dissolution of number of the salts. Different types of the salts are dissolved in that. That is, it contains larger percentage of the dissolved salt, out of which 2.6. That is NaCl is present in the dissolved form in the sea, which can be evaporated, which can be collected through the evaporation of the water, sodium chloride can be utilized. That is, nowadays we are utilizing this is used for the cooking purpose, and not only for the different forms it can be used. Now, another is the underground water. This underground water, whether in the form of spring, well, or these are the underground water. Now, they also contain most of the different types of the salts are dissolved in that. When it passes through the soil, where it will dissolve in the rocks or the mineral rocks are there. Through that, so number of the salts will be dissolved in that. Okay. So now next, as we discussed about the source of the water. In the source, we have the number of the impurities will be there. Why? Because as I said that while coming from in the rain, it may dissolve the number of the dissolved gases. And also along with that, in the underground also, it involves the dissolution of the minerals which are in the form of the rocks. So we need to discuss about the impurities. Different types of the impurities will present in the water. So, what are the types of the impurities are present? How the different types of the impurities are present in the water? We need to discuss here. So, here the impurities present in the water which are classified in the different ways. One is the dissolved impurities. These are the dissolved impurities. Now, these dissolved impurities may be the organic or the inorganic. The dissolved impurities. So, what is the organic? What are the impurities of the organic and the inorganic impurities? Inorganic impurities include the bicarbonates, carbonates, bicarbonates, and the sulfates in the form of calcium or the magnesium or the iron, potassium, and the aluminum. These are the different types of the salts. That is the carbonates, bicarbonates, sulfates, chlorides. All these we'll discuss in the further. If we'll go in deep into this chapter, we'll discuss about that, what they will cause, what are the effects. Now, organic impurities involve the dissolved form of the amino acids, proteins, etc. These are the different types of the organic impurities that are also present in the water, which are considered the dissolved impurities. Along with that, it may have the gases which are dissolved in the water. They are oxygen, carbon dioxide, oxides of the nitrogen and the sulfur, as well as the H2S. So, along with the dissolved impurities, it may have the suspended impurities. Suspended impurities means which will suspend in the water. Now again, these suspended impurities are of two types, that is inorganic, which are the example for the inorganic impurities are the sand and the clay. And not only that, that is organic impurities, that is whatever they will use. Most of the people, that is because without the awareness, they will throw everything into the water, that is a vegetable matter, animal matter, not only by the human cause, but also naturally that also it will go into the water, that is a vegetable waste and the animal matter will be dissolved, it will be in the float. That is why it is called as a suspended impurities, which will causes the toxic effect as well as the impurities in the water. These are the examples, that is inorganic and the organic are for the suspended impurities. Now coming to the biological impurities, that is biological impurities means the human beings, that is the microorganisms which are present in the water. Microorganisms like pathogenic bacteria, fungi, algae, etc. These are the biological impurities which are also present in the water. Now coming to if these type of the impurities are present in the water, what they will cause? Effects. What are the effects which are caused if such type of the impurities are present in the water? What are the effects? So that if we know the effects, then only we can able to find out, that is how we can purify the water for the further engineering purpose, utilization in the engineering field, right? So the disadvantage of the hard water, what they will cause, if hardness is present in the water, what they will cause, what are the effects, that we'll discuss. Now these are the disadvantages of the hard water when the hardness is present in the, now we'll discuss what is the hardness, that is impurities. Now domestic use, when we use in the domestic purpose, what are the effect of using the hard water, we'll discuss. That is when we are using the hard water for the washing and the bathing, The hard water does not form, it will not form the lather easily, means it will not produce any of the lather. Now, with soap, that also we'll discuss what is the composition of the soap and all when we'll go for the types of waters. Now, when we use for the drinking purpose, this hard water, that is like impure water, when you use for the drinking purpose, it will causes a bad effect on our digestive system. It will damages the number of the organs also continuously if you use this hard water, impure water. Okay, so now for the cooking purpose also, as you know that if we'll continuously use the hard water, the boiling point of the water is increased due to the presence of the salts. Pure form of the water is only the H plus and OH minus ions are present. So it required, that is at 100 degrees centigrade it will boil. But if any impurities are there, because of the presence of the impurities, it requires the high temperature to boil, right? So it increased due to the presence of the salts. Hence, wastage of the fuels will taking place. There is a wastage of the fuel. Not only that, it also causes the damage of the vessels also. Continuously if we'll use a cooking purpose, that is a boiling water or the cooking with that, it will causes the number of the effects, scales and the sludges like that, and also the breaking of the vessels will take place. Further, this is also one of the important, that is a disadvantage if you use the hard water in the cooking purpose. Now, in the case of the industry also, in the industrial usage, if we'll use the hard water in the industry, what are the effects we'll discuss now? That is, suppose if it is in the textile industry. In the textile industry, the hard water causes the wastage of the soap. When you'll apply for the material, any of the cloth, it causes the wastage of the soap, and also the precipitates of the calcium and the magnesium, which will adhere to the fabrics, that is, which will stick on to the fabrics, which causes a problem for that. That is a easy breakage of the threads will takes place when continuously soap is blocked on this cloth. Now, coming to the paper industry. In the case of the paper industry, calcium and the magnesium salts in the water, it will affect the quality of the paper also. That is there is change. Sometimes that is a decoloration, that is a coloring, yellowishness will also appear for that. It affects the quality, especially in the paper industry. And also in the sugar industry, when it contains the sulfates, the carbonates or the nitrates, it affects the crystallization of the sugar. That is, a crystal formation will be decreased. That is sometimes see, and also the yellowish coloration also appeared in that due to the effects, hardness in the water. And also in the pharmaceutical industry, especially this is very, very important, because the medicines which are used for the health agent. So now hard water may form some undesirable product while preparation of the pharmaceutical products. So this will cause, that is a very bad effect, bad impact will be there in the drug industry also if you use the impure water. Now, this is another disadvantage of using the hard water, that is a steam generation in the boilers. Steam generation in the boilers means, for steam generation, boilers are employed. If hard water is used in the boilers, it may lead to the following troubles. Now we'll discuss in this unit in detail, that we'll go for the further classes. I'll explain all the problems what will be affected in the steam generation if you use a hard water. Right. So now one of the important one is the boiler corrosion. Corrosion of the boiler, damage of the boiler, scales in the sludge formation. Scale formation, how it will impact on that. Now in detail we'll have the discussion in the separate, in our next video we'll discuss about the scales and the sludge formation. Different video in detail we'll discuss. And the priming and the foaming, caustic embrittlement in the pharmacy industry, as well as in the caustic embrittlement we can see in the steam generation also. Number of industries will face about this caustic embrittlement, the cause and the effect. That also will take the another full video for all these troubles, because these are the very, very important problems which are faced for the steam generation, right? Especially we are discussing the water as an engineering material is for the steam generation. So that is why we need to, all these troubles, the problems, we need to discuss in detail in the different videos. Okay, I'll explain all that. Now, so as of now, I have explained about the hardness. What will be the impact on the different field if we use the hard water? So what is this hard water? That is a hardness. What is this hardness as well as the hard water? And when we will call what will be present in the water to make it hardness, that we will discuss. That is a hardness of water. Now, how to find out the hardness of water? How to detect the hardness of water? That is, it is a property of water which prevent the lather formation. What is lather? Lather which is obtained when you use the soap, right? As a soap. Now, this is due to the presence of certain salts of the calcium and the magnesium which are present in that. See, hard water will stops the lather formation. Why? Because in the hard water it contains the calcium and the magnesium salts are there, which will block the formation of this lather formation. So, as we are discussing about the chemistry, so you need to understand what is the chemistry of the soap. Why? The soap, when soap is not producing the lather with the hard water, and why it will produce lather with the soft water. If you know the composition of the soap, then you can easily identify, you can easily say that how it is producing the lather. That is this is the soap, composition of the soap. Sodium salt of the stearic acid. This is stearic acid, sodium salt. Sodium, that is a C17H35COONH, the sodium stearate. Sodium stearate when treated with a, now see, suppose if you consider the water. This is a water. Now, in the water which is having the hard water, I am considering this as hard water because soft water is only H2O. But here, hard water having the salts of calcium or the magnesium. Suppose, for example, if you take the one example of calcium chloride is present in the water, which make the hardness to the water when reacted with the soap. Now, soap is the composition of the soap is sodium salt of the stearic acid. When reacted with hard water having the CaCl2, so what will happen? It will form the calcium salt of this stearic acid. That is a C17. Now, here 35 COONS taken to Ca, calcium salt. Now, this is a calcium salt is a white precipitate which is formed, which will prevent the lather formation, which is called as scum. This is called as a scum. Now, that is a calcium. If calcium or the magnesium, suppose for example, if magnesium chloride is there in the water, then it will form the magnesium salt. Magnesium stearate is formed along with this sodium chloride is formed. Now, this is a white. That is why, because of this, a white PPT has been formed when you use in your, if you test with a soap, dissolve the soap in the hard water, a white precipitate is formed. So, what is this white precipitate? This white precipitate is the calcium or the magnesium salt of the stearic acid, right? That is why, which will prevent the lather formation. Now, see the difference. Then, if you dissolve the same soap into the soft water, soft water means now here these are the present in the natural water also. That is okay. Now, based upon that, we can classify the water into the hard water and the soft water. So, as I said that the water, hard water is having the salts of the different, that is a calcium and the magnesium salts. Calcium and the magnesium salt of the chlorides, sulfates, nitrates, different types of the salts are there. These carbonates, bicarbonates, all these will cause hardness to the water. When we will take the water, soft water, this soft water, here the soft water is the water which are pure form, that is only the H plus ions and OH minus ions are there, H2O. Now, see, here the soap is a sodium or the potassium salt of higher fatty acid like the stearic, oleic or the palmitic acid, as we have discussed already that. Right. Now, this when dissolved in the soft water, this is the soft water. Now, when treated with a soft water, what will happen? Here you will get the stearic acid, that is a C17. Now this is a C17H35COONA. When reacted with the pure water, it will form the C17H35COOH, stearic acid. This is a stearic acid has been formed. Along with the liberation of sodium hydroxide. Now see, this is a sodium hydroxide is formed. That is why when you touch the water, after dissolving the water soap into the soft water, you can feel this with your finger. You can feel the sensation like gelatinous substance. This gelatinous is due to the formation of sodium hydroxide along with the liberation of stearic acid. That is why here this will produces the lather. A lather has been produced. You can able to see that. Lather with a slippery. This slipperiness is due to the formation of sodium hydroxide. Whereas this type of the slipperiness you cannot see when the soap is dissolved into the hard water. Where that is why, because there the only sodium chloride is formed, but here the sodium hydroxide is formed. In both the case, that is here this is stearic acid, sodium lather formation is up here. Okay. Now see, these are the different types of the reactions. Now, if this sodium stearate, when reacted with the hard water, see, when soap comes in contact with the hard water, sodium stearate will react with the dissolved calcium in the magnesium salts and produce this the calcium stearate or the magnesium stearate, which is white precipitate. Just now what I said that. This is a white precipitate, insoluble white precipitate. Calcium or the magnesium white precipitate has been produced. Okay. So, along with that is a sodium chloride. See, this white precipitate, which is also called as a scum. We'll discuss in the next. Okay. So, that is way with the soap test we can able to identify, can able to differentiate the soft water and the hard water. Soft water will give the lather with the soap due to the formation of, that is a sodium salts. Then also the sodium salt of the stearic acid, when reacted with the soft water, it will form the stearic acid along with the liberation of sodium hydroxide, which will give the slippery nature when you touch with the finger. Whereas hard water, that you keep in mind, that is why I am reminding once again to this, soap when dissolved in the hard water, it will form the calcium or the magnesium salt of the stearic acid along with the liberation of the sodium ions. That is, if it is calcium chloride, calcium sulfate is there, then is a sodium sulfate will be formed. That is why. So, here hard water will give the precipitate, whereas the soft water will give the lather. That you will keep in mind. Okay. Now, coming to the other, that is so how much in all the water, even what we said that rainwater also having some of the dissolved salts are there while coming from through its journey, it involves a dissolution of number of salts. So, how much percentage of the salt should be there to say that the water, whether it is we can use. So, to know that here the hardness, specific hardness should be there for the water. To say that here different types of the water have the different degrees of the hardness. We'll discuss. See, what is the degree of hardness? There is a degree of hardness. It is a measure. It is a measure of hardness to find out that how much hardness is there. Right. So, now here based upon the degree of hardness, the water has been classified again into the soft water, which is having that is here hardness around, if water is having around 0 to 70 milligram per liter of hardness is there, it is considered as a soft water, which is good for the utilization. Now, if hardness is about 70 to 150 milligram per liter, it is called as moderate hard water. Now, if hardness is about 150 to 300 milligram per liter, it is called as, considered as that point, it is considered as a hard water. It requires treatment before utilizing in the different purpose. Now, if it is greater than 300 milligram per liter, it is considered as very hard water. Very hard water, which cannot be utilized in the different forms, either commercially or the domestic purpose. It requires a lot of the treatment, different types of the treatment in order to utilize this water. Got it? Now, So after knowing that types of hardness, so we have discussed the type of the water, that is a soft water and hard water. In that hardness, how it will causes, which makes the hardness for that, what are the salts, calcium and the magnesium of different salts will cause the hardness. So in that hardness also, we have the different types of the hardness, that is the types of the hardness. Hardness of water is of two types. That is first type is a temporary hardness. Temporary hardness, which is also called as carbonate hardness. Permanent hardness or non-carbonate hardness we'll discuss. Let us discuss what is this carbonate hardness. It is bicarbonate hardness. Temporary hardness or bicarbonate hardness, permanent hardness or the non-carbonate hardness. So what is this bicarbonate hardness? Why it is called as a temporary hardness? Which salts will make the water temporary hardness, right? So temporary hardness is caused by the two dissolved bicarbonate salts, that is a calcium bicarbonate. Keep in mind, calcium bicarbonate, magnesium bicarbonate. This calcium and the magnesium bicarbonate makes the water temporary hard. So why they are considered as, so as these two salts causes the temporary hardness, they are called as temporary hardness causing salts. Temporary hardness causing salts. So why they are called as temporary hardness causing salts? Why these are considered as a temporary hardness causing salts? Because it can be removed easily by means of boiling. Simply by boiling, these bicarbonates of the calcium and the magnesium can be easily removed. That is why it is called as temporary. That is, hardness is only temporary. Simply just by boiling, we can remove the calcium and the magnesium salts of the bicarbonates. The bicarbonates of calcium and the magnesium. So this calcium bicarbonate, upon heating, it will form the calcium carbonate along with the formation of water in the with. Now we can see that if you take the water and take into the container in vessel and boil it, if boiling, continuously boiling, a vapors will come, that is in the carbon dioxide will move, that is a go outside in the form of the vapor. This will go out in the form of the vapor along with the liberation of the CaCO3 particles you can able to see on the upper layer, as well as in the formation of the scale. That is the scales and the sludges we'll discuss in the next topic. That is, see here, so calcium carbonate will be removed along with the liberation, that is along with the formation of water. A pure water has been formed just simply by boiling. That is why these two salts are called as temporary hardness causing salt. So the water which are having these two salts, they are temporary hardness water, temporary hard water. Okay, now coming to the permanent hardness. What is this permanent hardness? Which salts will make the water permanent hardness? So for that, permanent hardness of water is due to the dissolved chloride, sulfate, nitrates. Chlorides, nitrates and sulfates, these are the anions which make the, now of the calcium and the magnesium. Calcium and chloride, nitrate, sulfates of the calcium and the magnesium make the water permanent hardness. Now see the difference between the temporary and the permanent. That is in both the cases the cation will be the same, just anion will make, change in the anion will make the difference in the hardness. That is, anion, if the chloride, nitrate and the sulfates are present in the water, that will make the permanent hardness, whereas bicarbonate, HCO3 2 minus, that will make the, HCO3 minus will make the water temporary hardness, right? So this is a temporary hardness and this is a permanent hardness. Okay, so and both are the calcium and the magnesium salts only. Now, so this hardness can be removed easily, cannot be removed. As I said, that temporary hardness can be easily removed by just by simply boiling. But permanent hardness cannot be removed by the boiling. It requires the chemical treatment. Different types of the entities. Only chemical treatment can remove the permanent hardness. That also we'll discuss in our next video. We'll discuss about how the permanent hardness can be removed by the different techniques are there, which by which we can, nowadays the technology is advanced, so that we can able to remove even the seawater also we are using for the different purpose by means of chemical treatment. Okay, so what are the chemical treatment for the removing of the permanent hardness can also we'll discuss in our next video. Okay, so as I said that this hardness can be discussed, that is a measure. It is a degree of hardness. The concentration of the hardness as well as the non-hardness constituting ions are usually expressed in terms of equivalent of the CaCO3. This degree of hardness can be measured with the equivalence of the CaCO3. Why? What is the speciality of this CaCO3? Why? Degree of the hardness can be calculated with the CaCO3 equivalent, because here the atomic, now see, here when required, the choice of the CaCO3 in particular due to its molecular weight. The molecular weight of the CaCO3 is 100, which is easy for the calculations. Not only that, all the dissolved salts which are present in the water will be precipitated in the form of CaCO3. So that is why CaCO3 equivalent is used as a measure for the finding the degree of hardness. Okay, so now like 165 parts by the calcium bicarbonate is there. Like this, all these can be calculated for the different types of the hardness can be calculated by using the CaCO3 hardness equivalent. Okay, now as discussed about the degree of hardness can be calculated by means of using CaCO3 equivalent. Now we need to know that units. What are the different units of the hardness? How the units will be measured? Different forms of the units. That is one of the important unit is the parts per million, ppm. This is a ppm. This much ppm of the water is present. That is hardness is present in the water. Like that we can measure, right? So parts per million ppm. ppm is a number of parts of CaCO3 equivalent hardness per 10 per 6. 10 per 6 parts of the water. 1 ppm is equal to 10 power 6 parts. So that is a CaCO3 equivalent per 10 power 6 parts of the water. That is a measure. One of the important measure, that is a ppm. Now, milligram per liter, mg per liter. This is also another unit in order to give the, that is for the measuring the water. Milligram per liter is a number of milligrams of CaCO3 equivalent hardness present per liter of water. Number of milligram of CaCO3 equivalent hardness present per liter of water. This is a unit, that is considered as milligram per liter. 1 mg is equal to 1 milligram of CaCO3 equivalent of 1 liter of the water. Okay. Now, see, that is why it is a 10 power 6 milligrams, 1 liter. Now, so 1 milligram per liter is equal to 1 ppm, because here that is there in the ppm also will come, we have considered as a 10 power 6 parts per million parts of the water is there. So 1 milligram per liter is equal to the 1 ppm. Another unit to measure the water is a degree of clerk. Degree clerk. Now, degree clerk is a number of grains of, that is 1 by 7000 lb pounds of the CaCO3 equivalent hardness per gallon of water. So it is considered, that is defined as number of parts of CaCO3 equivalent hardness per 70,000 parts of the water. 70,000, that is a gallon. 70,000 parts of the water. 1 degree clerk is equal to 1 grain of CaCO3 equivalent per gallon of water. So finally that is 1 ppm is equal to everything. That is, if we'll go for that, all that relation also we'll discuss. 1 ppm is equal to 0.07 degree clerk. If it is, and 1 ppm is equal to 1 milligram per liter. 1 ppm is equal to 1 milligram per liter is equal to 1.07 degree clerk. So this is a 1 ppm equivalent. Now another degree, then another unit is a degree French. That is a degree of French. Degree French is a number of parts of CO3 equivalent hardness per 10 power 5 parts of water. 1 degree French is equal to 1 part of CaCO3 equivalent per 10 power 5 parts of the water. So 1 degree French equal to how many ppm? That is a 0.1 degree French. 1 ppm is equal to 0.1 degree French. That we need to keep in mind. 1.1 degree French is equal to 1 ppm. The hardness of the water can be converted in all the 4 units of the following. That is a C. Now see, 1 ppm is equal to 1 milligram per liter as already we discussed, and 0.07 degree Clerk and 0.1 degree French. This is a conversion which is very important for the numericals. For doing numericals also I will discuss. Right. So 1 ppm is equal to 1 milligram per liter, which is equal to the 0.07 degree Clerk, which is equal to the 0.1 degree French. This is the interconversion of the interrelation of all the units. Okay. Now, so these are all units. As I have referred from the different textbooks of the engineering chemistry or to give the knowledge. So thank you for having the patient continuously listening about this one. Now in this video we have discussed about the importance of the water as well as the source of the water, importance, sources and the hardness. If hardness is there, how it will affect on the different fields and types of the hardness. What are the temporary hard water, temporary hardness causing salts and the permanent hardness causing salts, and how this hardness can be measured, that is a units. These are all we have covered in this video, and in our next video we'll discuss about the troubles as well as the different, that is in this water and its treatment. The different topic will come with a new video. Thank you.